welcome back to TensorFlow. In today's video, we are going to solve two real-world problems of binary search algorithm on LeetCode. So, in our previous video, we have discussed that what is binary search algorithm, how does it work, and where we use it. So, in today's video, we are going to implement that knowledge in our LeetCode problem. So, as you can see, this is the problem number 704 on LeetCode of binary search. So, this is the given problem, and we have to solve it. So now let's first read the problem. Given an array of integer, the name of array is nums, which is sorted. So as you know, we can only apply binary search on sorted array. So we have sorted array which is called nums. We have to find target. If target is in the array, if target is found in the array, then you have to return the index where it was found. And if the target is not in the array, then you have to simply return -1. So we have to achieve this time complexity. If this time complexity exceeded, then our code will not work. So these are the examples. As you can see, 9 is in the array, so we have to return the index position of this, which is 4, which means 9 exists. And if the target value is not in the array, then we have to return -1. So now let's start coding this on our LeetCode prompt. So before coding, you first have to understand that what are the steps you have to take for solving binary search problems. So this is actually a cheat code for solving DSA problems on LeetCode, which is first you have to make some steps in your mind, and then you should start solving the problem. So as you can see, these are the necessary steps that you have to take for solving binary search algorithms. So first we will initialize two pointers, which is left and right. So we will initialize left from 0th element or 0 index, and right from the last index. Right will point on the last index of the array. So to find the last index, we just have to use length function n -1. So as you know, indexes usually start from 0. So the last index will be the length of array -1. Now we have initialized left and right pointer. The second thing is to start a loop, but before starting the loop, you have to know that what is the breaking condition of that loop, where our loop will stop. So in binary search, if the left pointer and right pointer, if left pointer and right pointer cross each other, our loop will stop. So to write that, we will use a while loop, and we will simply write that if left pointer is equal to or smaller than right, then our loop will work. Otherwise, our loop will break. Now, in loop, we have to calculate the mid value of the array, which is the middle element of the array. So, the middle index, to calculate the middle index of array, we have a condition, which is this. To calculate the middle, we will use this formula: left plus right minus left divided by 2. We are using this because we want base value. We don't want 3.5, we just want 3. So, we want base value, so we are using this operator. So, I'm working with Python. You can use any other programming language that you want. The syntax will be different, but the approach and algorithm will be same in every language. So you can use any programming language that you want. So now we have to calculate the middle element. So to calculate middle element, we will simply write left plus right minus left divided by 2. This will give you the middle value and the base value of that thing. Now, as our next step, we have three conditions. The target value is equal to the middle value, the target value is bigger than the middle value, and the target value is smaller than the middle value. So if the target value is equal to the middle value, we will use if the target value is equal to the middle value, then we will return the index of the middle value. And else if the target value is greater than the middle value, nums of m. So if the target value is greater than the middle value, then you have to search on the right half of the array. As you can see here, if the target value is let's say the target value is 7 and the middle element is 5. If the target value is bigger than the middle element, then you have to search on this side. If the target value is 4, then you have to search on this side. So if the target value is greater than the middle value, then you have to adjust your left pointer. So we'll shift left pointer on the right of middle element. So now the last condition is if the target value is smaller than the middle value. So we will wrap this in else statement, and we will simply adjust our right pointer by m minus 1. Now if the target value is equal to the middle value, then we will return m. If the target value is greater than the middle value, if the target value is greater than the middle value, then we will shift our left pointer here. If the target value is smaller than the middle value, then we will shift our right pointer here. So now our last condition is if the element we are searching for is not in the array, then we have to return minus 1. Now these are the this is the code for binary search algorithm. Now let's run it and see that what are the results. So as you can see, we have passed all 2 test cases here. In this the target is 9 and the target is on 4th index, so the output is 4. And in second test case, the target value is not in the array, so we have returned minus 1. Now let's submit the code and check that what is the accuracy of our target value of our code. Test case accepted. So we have achieved 100% accuracy. The time complexity is under the limit, and the memory is used is this. So yeah, we have solved this problem. Now let's jump into the next problem, which is search insert position. Problem number 35. This problem also uses the binary search algorithm. Now let's read the question first. So the question is, given a sorted array. By sorted array, we understand that it is binary search algorithm, means it is binary search problem. So of distinct integer and a target value. Return the index if the target is found. If not, return the index where it would be found. So in this problem, we have a return minus 1 where the target value, if the target value is not in the array. But in this problem, we have to return the expected value, expected index of where the target value would be found. So the approach will be same. First, we will write the binary search algorithm code, which is we will initialize left pointer and right pointer, uh, left pointer and right pointer. After that, we will start our loop until it is until left and right pointer cross each other, and then we will find the mid value, which is left plus r minus l plus 1. Oh, sorry, divided by 2, r minus 1 divided by 2, and after that we will check if the middle value, if the target value, target if the target value is equal to the middle value, then we will return the index where it is find. And if the target value is sorry if the target value is greater than sorry smaller than nums of m, which means middle value. If the target value is smaller, then you have to search on the left half, so you have to adjust the right pointer. So to adjust right pointer, we will write r equal to m minus 1. So we have to search on the left half. Else we have to search on the right half. So to search on the right half, we have to adjust our left pointer, which is m plus 1. Now if the target variable or the target value is not in the array, so we have to return the expected index value where it would be find if it was there. So to do that, we simply simply have to visualize that uh, will where we will find the target value if it is not in the index. So let's say we are searching for 3. In this case, we are searching for 3. So first we will initialize left and right pointer, calculate the middle one, let's say 5. And then the 5 is 3 is smaller than 5, so we will search on this half. So the middle value is, let's say, 2. And now no, sorry, the right will shift to here, and the middle value is this. And after that, we will search if the target value is smaller than or greater than this. So the target value is greater than, so we have to search on this half. Now our middle value is this, left value is this, and right value is also this. So the target value is here is target value is 3, but the value we found is 4. So we have to simply return this index, which is where the left pointer is pointing. So we will simply return the left pointer, the index where left pointer is pointing. So we by this we can return the expected value, expected index of that value. Now let's run the code and check if it is right or not. So yeah, we have passed all 3 test cases. So this is how you solve LeetCode problems of binary search very easily. You just have to, so we have got 100% accuracy. So we just have to visualize the steps before solving the problem. You just have to visualize the step, and the most important thing is you have to understand that where our loop will end. So this is the video, guys, and that's it for today. See you in the next one.